Hello, I hope you're all doing well. In this video, we will find the pH of buffer solution. Now, what is buffer solution? It is a solution which resists the change in pH when you add small amount of acid or alkali in it. And the simple example of buffer solution is it is a mixture of weak acid and its salt. So if you have weak acid and if you have mixed it into its salt, that mixture is basically buffer solution. So we can write its dissociation constant expression. We know that it is concentration of product or concentration of reactant. We always write it for those reactions which are reversible. So if you will assume that like this is the dissociation constant expression for the weak acid only. But right now we have mixture of weak acid and its salt. So this time the dissociation constant expression is slightly different. Now, I will just remind you that why we have taken H plus square when we were writing the dissociation constant Ka expression for weak acid. We assume that the negative and positive ion in the weak acids are equal. So instead of writing them separately, you can take its square. But this time, the concentration of H plus and negative ion is different because H plus is just being formed from the dissociation of acid, but the negative ions were formed by the dissociation of acid and salt as well. So their concentration this time is different, so you will write them separately. Okay, so this is the dissociation constant. You can use it to find the concentration of H positive ion, rearrange this equation, and then you can use it to find the concentration of H positive ion. Once you will get the concentration of H positive ion, take its minus log, you will be able to get pH. Or you can also use the other equation, Henderson equation, directly to find the pH of buffer solution if you know the concentration of salt and concentration of acid. Now we will solve an example question. This is exam question, so we will solve it to find the pH of buffer solution. In this question, we have acid and sorry, this is the salt and we have acid, ethanoic acid and sodium ethanoate. So acetic acid and sodium ethanoate, these are our components of buffer solution. And in this buffer solution, they're saying that a sample of 5 centimeter cube of 2 mole per dm cube hydrochloric acid is added to this buffer solution. So we had a buffer solution which had CH3, COOH, our ethanoic acid, and CH3, COONA, which is sodium ethanoate. So this is the buffer solution. But we have added hydrochloric acid in it, which is a very strong acid, so it will change its pH. And they expect us to find the pH of that solution when you will add HCl in it. And we are given with the value of dissociation constant value of acid. Okay, so what we will do whenever you will be asked this question to find pH of buffer solution, just remember that in the end you will need the concentration of H positive ion. To take its minus log, you can get pH. And for concentration of H positive ion, we should have the concentration of acid and concentration of salt. This A negative, the negative ion basically, we assume that all of these negative ions are formed by the dissociation of salt only because the acid dissociate poorly. Its dissociation will happen partially. There are very less number of negative ions which are being formed by the dissociation of acid. So we assume that all of these negative ions, which in this expression are A negative, all of these are formed by the dissociation of salt. So if you know the concentration of salt, you can basically use that exact same value of concentration of salt for the concentration of these negative ions. So basically that's why if you will write for this A negative, you can say that it is basically concentration of salt and this is the acid. Okay, so and one more thing, we don't need to find the concentration basically. Concentration is equal to moles over volume, right? So concentration of acid is moles over volume, concentration of salt, mole over volume. So because all of these components are present in the same solution, so the volume will be exactly same for all of these. That is why these values will be equal, so you can cancel these out. But their moles will be different, we cannot cancel those. So instead of finding their concentration, you can simply use their moles only. It means that to find the concentration of H positive ion, right now, I need to have the moles of acid and its salt, right? So we are finding the moles of acid and moles of salt. So what we can do here, that use the given information, use the moles, find the moles of CH3COOH. We have its volume, its concentration, change that volume into decimeter cube by dividing it with 1000, and then we have got this value. Then we have moles of HCl. How we have found that? We have volume and concentration of HCl. Use those values to find the moles of HCl as well, which we have added later on in our buffer solution. Now, when you will add buffer solution, we know that in our buffer solution, we have only these two components. So when you will add HCl in the buffer solution, their amount will change. So how the concentration of buffer solution, or the different components of buffer solution, will be affected when you will add HCl. So when you will add HCl, the concentration of H positive ion on that in that solution will increase. So this equation will move to the left side, right? According to the Le-Chatelier principle. So when you will add acid, because of more H positive ion, the equilibrium will shift to the left. So when it will shift to the left, the concentration of these negative ions will decrease and the concentration of acid will increase, right? So we have already calculated the moles of acid, but we know that when you will add HCl in it, the moles of acid will actually increase. How much these will increase? The moles of HCl, which are 0.01, we have added these into the solution, and meanwhile, the equation will go reverse, and you will have more and more CH3COOH. So their moles will increase by 0.01, and the moles of these negative ions will decrease. And we just remember that we are taking these moles of negative ions equals to the salt. So this is how you will proceed with the calculation. So moles of acid are increased by 0.01. So your ultimately your moles will be 0.05. And the moles of CH3COO negative will decrease as the equation is going to the left side. So the moles of CH3COO negative will decrease by 0.01. So you will subtract these moles from the actual moles of CH3COO negative. So as you can see that the moles of salt were given 0.025. We have used those moles. Remember, their moles were equal. So we have used those moles to find out the moles of these negative ions. And now we are saying that the moles of these negative ions are decreased by 0.01 because we have added acid, and equation. The first equation is reversed. It is moving to the left side. Okay, so now we have got the moles of CH3COO negative, which is this one, and moles of acid, and then you'll simply put those values into this expression. We have value of Ka from our question, when you will have the concentration of H positive ion, which is right now 5.28 into 10 raised to power minus 5. You will take its minus log, and you will be able to get pH. So just follow this step. Make sure you have concentration of H positive ion in the end, and just find out the concentration or moles of acid and salt of buffer solution. Now it's your turn. Practice this question. Pause the video for a few minutes, and in the next slide I have marking scheme, so I will show you the marking scheme. You can check your answer. Here you go, and that's it. Thank you. See you in the next video.